Hello everyone, I'm sure you're doing awesome. So in this video, we will try to decipher a very important database, low level internal mechanics, like how exactly the data that we see as a result of our select star or as a result of our insert into is actually gets stored into our disk, right? So database, like for when we are talking about the Oracle or Postgres, they are database engines, and those engines are in some way storing the data into the actual operating system disk and retrieving the data from there. So we are going to understand those internals, and these internals are very, very essential to understand the extended concepts, like the indexes, or then when the more advanced things comes like the sharding. So let's understand one thing, that when we see the data, for example, something like select star from, suppose there is a table name we are providing. Okay, so this is just a logical view. Okay, so when we are looking into this, this is nothing but a logical view. In this logical view, what happens, that we are seeing the data in a certain structured manner, but in the physical storage the data is entirely different. So suppose like I'm just putting something like this: insert into orders. There I have order ID and then customer name, amount. For e-commerce, suppose Amazon, I am trying to get my orders table up and running. So here, suppose I am putting the values as 1, I'm putting the name as Virat, and the amount as 250.0, something like that. Okay, so we see that here, as a database developers, what we have done is, these are nothing but, all these things that we are seeing, these are nothing but some column names, right? And this particular data that we see over here, this is nothing but our row. This is nothing but our row data, right? So now internally, uh, in DB, this particular database that we are talking about, this database is nothing but it is running over here in this particular host machine only. So this particular database instance, like all its memories or all the data that it stores is definitely into this host machine OSS, host machine operating systems hard disk, or SSD, or any kind of commodity hardware that is being using. Okay, so let's try to understand what exactly happens when we run this select star from or this insert into internally. Okay, so here we are going to explore the anatomy of the insert into statement, right? So here there are so many components are involved, which we will go through one by one. So do not get overwhelmed by the whole list. So initially just understand this thing, that when we are writing any program, like be it a C sharp, be it C++, or C program, or any kind of other things, so it generally goes through a parser, right? For example, to make sure that the DB engine and the application, they understand the language of the developers, like when we are putting things like insert into, or update set, or select some column name from some table name, at that point of time, just to make sure that this that particular translation happen properly, it initially goes through something called a SQL parser. So what this parser does, it tokenizes. Okay, so this particular step, when we see, if we just write it in more like a generic manner, it just tokenize it for the understanding, for the better understanding of the DB engine system. Okay, and it tells that and it also creates something like abstract syntax tree, which we do not have to worry about much right now, but just understand this thing. uh, this particular insert into statement get tokenized, and after it get tokenized, then it get fed into a query planner. So what exactly query planner, we will going to explore in a far more bigger detail in our next video. But here just understand this thing. This planner creates an execution plan. So this is a very important term, I would say. So execution plan. And what exactly is the execution plan? So execution plan determines like how the query should actually travel from. Okay, so we will go in further detail into that, but execution plan would make more sense when we understand the details of the paging, which we will cover in this video only. We will understand the detail of the paging, heap, and all the other details. Okay, so once this query plan or the execution plan is being created, so this execution plan then being fed onto the actual DB engine. Here you can see it will go to the execution engine or the DB engine per se, anything we can say. Now the executor coordinates the actual insert. So here what it does is it requests the actual target page. Now you must be wondering, like, you haven't mentioned anything regarding page, right? What exactly is a page? I don't understand. And from here only the actual magic happens, that the page, buffer pool, everything will come together. So just be very uh, uh, put your 100% concentration into this area right now. So what exactly is a DB page? DB page is nothing but a fixed size block storage. Okay, but anyway, it is completely different from the OS pages. So how the OS pages and the DB pages will come together, that too we will discuss. Okay, so these are nothing but like a fixed size block storage which we get from uh, the actual operating system disk. And this block storage, what they do is they hold one or more rows. So like for example, if a table, suppose a table have like 10,000 rows, okay, or yeah, 10,000 rows. So out of that 10,000, suppose it have like 4 pages. So it might happen that every page holds around 2500 rows or records here. Okay, and databases, this read and write the read and write all the information into this page size chunk only, not in exact individual rows. So as we were discussing that how DB pages and the OS pages are different, so what database pages are, they are like logical units managed by, so DB pages are managed by our DB engine, whereas the OS pages are actually, like when we are talking about the OS pages, they are actually the physical memory pages that are managed by OS itself. So as you understand, the source of this the DB pages are definitely coming from the actual physical memory pages, right? So when a DB engine generally needs a page, what happens is it at first looked into the buffer pool. Now you might be wondering, you have uh, you have again introduced one more jargon called buffer pool. So what exactly a buffer pool is? Let's understand. So buffer pool is nothing but cache for the DB engine. So you must have noticed one thing. So suppose you have run a select some column name from some table name, right? And what you might have noticed there, that this column name from table name, at first it might take like time of 2 seconds to get the data, but in the subsequent calls it takes like probably 30 milliseconds. Why it happens? Because the moment database or the database engine determines that something is there on a certain DB page, it caches that particular DB page. Okay, and where does it get cached? So when we are talking about any page, so this page that you see, okay, so, or rather let me be more clear, DB page. So DB page has number of rows as record, right? Now what happens is this particular DB page, it's cached into the buffer pool. Okay, so what happens in this scenario is all the reads and writes generally goes through this buffer pool. Okay, and if a page is not in memory, it then gets fetched from the actual operating system disk, loaded into the buffer pool, and then it is being returned to the final the client app or whoever the caller is. So I hope this part is clear, that what exactly is a database page is. Database page is nothing but a fixed size block storage, but they are significantly different from the actual operating system pages. Okay. However, when DB page, like we need a new page, suppose you have 20 DB pages in place, like as we were talking about, there are 4 pages, right, of 2500 rows, and now suppose it is being full, then from here what will happen is, because it is being full, so the next insert the next insert into would be in a new page, right? Because all of the 4 pages are full, so the next insert into will require a new page and would need to go to a new page, and this new page DB engine would request from OS. So actual OS pages will be returned, and then DB page based on its fixed block storage. So suppose OS returns you something like a 128 KB sort of a page, but like this DB page size, like different databases have different DB page size. So suppose you only need 16 KB. So you create a fixed size block of DB page of 16 KB. That's all. Done and dusted with this, right? So now let's revisit this thing. Like we have fired an insert into, and from that insert into, that insert into gets tokenized, and after getting tokenized it get converted to few the actual values and then being fed into the query planner. We will come like at a later point of time. Then query planner outputs the execution plan. That execution plan is being fed into the execution engine. So now what does this execution engine does? So this execution engine will try to see if any particular page with space, okay, whether page with space is there in buffer pool. Okay, so this is the first thing it tries to determine, that whether there is a page that is available into the buffer pool. So what it does, it will just go there and do a some sort of a get page for this particular table. It will try to get a page, and if it gets the page, it return the page, or from this level it will generally return the page in case it gets it. Okay, so these two will go hand in hand. If it doesn't get, then what would happen? Then it goes to the actual DB page file lists. And who holds that file list? The file system has all the file list, right? So now from here, in case of not found, this is the not found case that we are covering. When we are not finding this one, when we are not finding this one, then what happens is the OS page, or rather from the OS, it creates a request to uh, get the db page file. So for example, the generally the db page file is something like, in our case it is like a orders dot dat. Okay, so orders is our table and dot dat is the data file. So it requests that give me this db page file. So this is the db page file, suppose. So in some way it gives you the db page file, and or it requests this db page file, and it tells that this the db page is now being returned. Okay, this order dat file, suppose it has a like multiple db pages, so that page will be returned here. So this will return the page, and because it will be acted upon, so what happens is the buffer pool, the buffer pool will be holding this particular page. So now that the execution engine know that the buffer pool has this particular page where it can update, so it will now start issuing the actual insert into. So now what would happen is it will try to see if there is any free space or not. For example, suppose till this area the data is already being filled. Okay, so this area suppose already being filled, and we only have some space left here. So it will know that it is going to insert into that particular free space of that page, and it is going to do another very interesting thing, that is, or it is going to involve another very interesting thing that is known as write ahead log, or WAL. Okay, so what it does is, it at this point of time in the buffer pool, it fires the actual insert, and this insert of course gets reflected into the actual db page. Okay, but this db page is still on my buffer, right? This db page that we are talking about. Now what happens is, there comes the role of the WAL, or the write ahead log, as very important. Okay, so what exactly a WAL or the write ahead logs are? So WAL is nothing but is a critical durability mechanism. It is a durability mechanism for the database. So suppose in some way over here that we were talking about this, like we see that after after putting the data, in some way or other we see that our database engine or something has completely crashed. So write ahead logs gives us some kind of a fallback in that case. How? Let's see. So what happens is, suppose we are writing this data modification, right, this insert into statement into our database. So the fundamental principle is like log the change before applying to actual db. Remember, at this point of time when we have written the data to the buffer pool and then into the db page, we haven't written into our file system or the persistent storage yet. Okay, so this data actually like is actually coming from the persistent storage, so I should have extended it further. So db page file or the orders bat, so this data is not yet written to the persistent storage. So before writing to the persistent storage, wl comes in play. So after the executor like identifying the page and before modifying it, like before even this step, so if I see that this is kind of a step number one, okay, and this is kind of a step number three to update a database page. In a step number two, what happens is that database execution engine over here, the database execution engine in the step number two, it writes the possible transaction details to the write ahead log or the WAL. So what gets written into the WAL and what is the structure of that? So the structure of the WAL is something like that. So the WAL sort of content something like a log sequence number or LSN as we say, and it will have something like transaction ID, the operation type, in our case it will be a insert into, and then things like the table identifier. It doesn't take the table name directly, but it takes the table identifier, page identifier, like the particular page it is inserting the data into. So all those kind of details, and alongside of course a very important term is timestamp. Everything is get inserted into the WAL. And how it is very much advantageous, suppose you want to take a backup of your whole data. So now in this way you have your complete replay of whatever the transaction or whatever the action that has gone into your database. So what we can do is we can just replay our WAL, and by replaying the WAL we can easily create a database backup file out of from our database. Even a real time database backup file we can create from our existing WAL. So now as per this stage, like when we have written the DB page a certain value and we have written the WAL, at that point of time we know that the page that was already existing in the persistent storage, right? The order under the order.bat. So suppose it was the version, if I mark it as version 1, now after writing there is a new record has been inserted. So the version has been changed, like it has become version 1 to version 2. But database doesn't understand by this versioning. What happens over here is database marks this page as a dirty page. Okay, so it will tell that the data that you are going to get from this page, if you are getting the data from the persistent storage, that might not be the accurate one, because I have already made a change into this database page from my buffer pool, and I have also written the possible transaction that are going to get executed into my WAL or into the write ahead log. So now at this stage, after all these things are done, when the actual database commit is being fired, so I hope like you have watched the previous two video, how important a commit is, what exactly a transaction is, what exactly is a unit of work, everything we have covered there. So when a commit is being fired, what happens at that point of time is some internal mechanism called Fsync or the flush that happens. So in this case, what happens is the moment the commit is being fired, as I said, like there is something called Fsync. Okay, something called Fsync also is being fired. So what exactly is a Fsync? So Fsync is kind of a flushing mechanism. Okay, so Fsync is nothing but a flushing mechanism. So it tells that all the records that are in the WAL and all the pages that are being marked as dirty, so at this particular time what I am going to do is I am going to flush all the changes to my persistent storage. So Fsync guarantees that the data reaches the disk platter or the SSD controller, whatever you are using. Okay, so WAL has some other internals as well, like how it is being managed into the segment. But just understand this thing: the WAL, right, is kind of a periodic and a uh, s- synchronous operation. So what happens is like maybe in every 12 milliseconds and every 50 milliseconds or in every 1 second, the data keep on saving its data based on the configuration. So this is something like we can configure on our database engine and on the other level, like how frequently we are going to do the Fsync. And we can even take a time, like for example 2 or 3 seconds. Suppose you are creating like a large WAL file and you do not want the immediate transactions, like immediate uh, r- read and the right you do not know, or you do not need, you just keep on writing the data. So in that case you can give a little bit of more time between the fsync. So what happens is, for the WAL, right, it's a synchronous mechanism. Like in 100 and 500 byte per insert, the data is getting inserted or getting appended, I could say, into the log file, and it is a very like a microsecond operation for the SSD. And what happens is, this data page, whichever is being being marked as dirty, they are being flushed into persistent storage. So one thing might confuse you, like what exactly is the role of the WAL and the actual dirty DB pages here. So WAL, please understand, this is being done immediately, but when fsync calls, then only this getting flushed out. So right now, to complete this exercise, what we are going to do is, we are going to create the total timeline of whatever the things that we have learned in this whole flow, so that this complete flow is uh, clear to us, like from our insert into fire up, how the data at in the end through fsync is getting stored into the persistent storage. So let's close in our discussion to understand the interplay between the WAL and the dirty page on the disk commit. What happens? So here, from the client end, our ultimate aim is the persistence. Like we want to take the data of this insert into, that you can see this query that we have written, this insert into the values, and it should go to the persistence, right? So at first we are executing the insert, and after executing that insert we are getting a certain page. Suppose here we are getting the page number 42, and we are returning the same page from the buffer pool. Suppose in the first place it is existing in the buffer pool. If it is not existing, what would happen? It would get the data from the persistent storage, store it in the buffer pool, and then return it. Okay, so just to make it a simpler for us, now we are just thinking that it is existing in the buffer pool. Okay, so and to clarify, if it is not there, it will just go to the actual persistent storage and come back to the buffer pool. So uh, over here, what would happen is, this guy, after getting the page, it will mark the, it will make the change in this particular page. So whatever the row that it needs to add it will add, and it will mark it as a dirty. So now we have a dirty page in our buffer pool, and alongside that, a very important concept of while or write ahead log comes in play. What write ahead log is does is, it does the transaction guarantee that before the data is being written into the persistent storage, it is being written into the WAL. So this fsync you can ignore right now. So once the WAL is persisted, we know that we are okay for the transaction committed. So till now here the transaction is not actually committed. Okay, transaction is here okay to be committed. Transaction is okay to be committed. So now what would happen is, this page 42 is still dirty, right? So then when we actually fire up a fsync, so fsync can be fired in many way. For example, in every 15 millisecond the database can periodically call fsync, or there can be some other mechanism as well. For example, during fsync, what happens is, it will scan for all the dirty pages. Okay, so not only my particular page, suppose the database is doing, like suppose that has done 10,000 operation in last few milliseconds. Okay, so it will scan for all those dirty pages, and what to do is, then it will uh, just send those particular data in into our persistent storage, okay, through fsync. And after the data is being written and we get this particular acknowledgement that you are seeing over here, after getting this acknowledgement, this is modified flag that we have uh, set up. The is modified, what it has done is modified has marked that this particular page is dirty. So is modified is being marked as false again. So here all changes are being written onto the uh, WAL, that is the write ahead log, as well as it is being persistent into the our actual OS storage. And again, what exactly is the important of WAL here? So WAL help us to replay all of our transaction at any point of time. So even suppose in between this step, okay, in between these two step, like when we are firing up our actual Fsync, when we are firing up our actual Fsync, suppose in this time our database crashes. Okay, here suppose our database or the OS which is holding it, it crashes. So next time when the operating system restarts, it will start reading from the WL. Okay, so on OS restart, as in recovery, on OS restart, it does integrity check. As in recovery, for the OS restart, it does a integrity check, and through this integrity check, we will be able to find out that all the data that are being written to our persistent storage or not, and if anything is existing in WAL which is not being written into our persistent storage, or some transaction is yet to be committed, then we commit those transaction into our permanent storage. So we have touched upon four very major concept for the database file system storage or the DB data storage, how it happens. So the first thing is like basically the DB pages, and there we have determined how exactly the DB pages versus OS pages they differ, and how like each DB page is being bring into the memory, and on top of it we generally work. Okay, so this is a DB page and the OS pages are there. Other than that, what is there? So there is this DB engine that we discussed. Like DB engine is the one who is responsible for all the executors. Other than DB engine, we also discussed about buffer pool. So buffer pool is basically nothing but the caching of the pages. Suppose like as one of the example I have given, like the first select query takes a little bit longer than the subsequent select query, because the table from which we are doing the select operation, it generally comes into the buffer pool. So we get those idea of it. And what this buffer pool does is like it acts as a cache. So there are few important points. It acts as cache one. The second thing is all read and write goes through this. So once like there is no direct file system changes happens, right? So any changes that we do, like here probably you understood over here when we have been discussing, any changes that we do, those changes are being done onto the buffer pool, they are being marked as dirty, then only they are being sent into the actual persistent storage when we are committing our transactions or through the Fsync. Okay, so let's write it in a more formal way. All read and write goes through this. In case any, suppose page is not in memory or in buffer pool, it is fetched from disk as we have seen and loaded into buffer pool. Okay, and once the page is modified, it is marked as dirty and eventually flushed back to disk. And then again, like in this time point of time, it will be marked as clean. Okay, so this is one of the important concept that we touched upon. So other than that also, like we discussed about the page management. Okay, so page management is nothing but what is happening is like how a new page is allocated, how a new page would be allocated. if I have to ask you when, in case like you have been thorough whatever we have been discussing, the new page is allocated when there is no free space. Okay, so this is a very important thing, like the page management. A new page is being allocated through the page management. A new page is being allocated, it is being given by the operating system, and DB engine then do it as per its own size, like 4 KB, 8 KB, 16 KB, whatever is required. And then what happens is data is inserted into new page. If old page has space, then data will be inserted there. Okay, so this is one of the very important concept we touch upon. Then of course WL. So WL is nothing but like, before modifying actual DB, the engine writes a log record to this write ahead log or WL. And why it is required? To ensure that it is durable. So the database durability that we generally talk about, this is one of the very important concepts around it. And it is written to disk, or like we can say like this is the first level of Fsync. I would not confuse you with this two Fsync, but this is written to disk before the transaction acknowledgement, or like before even the final commit. And then one more important concept that we touched upon is the background flush. In background flush, what happens? Like the database pages are not written immediately to disk. Okay, a background writer periodically flushes them to disk. So the dirty pages are being scanned, as we have seen over here. The dirty pages like are being scanned periodically, and F-synced. Okay, F-synced into our persistent disk. Okay, and this improves performance and like allows batch write, and we can generally control it. So this is very useful overall system. So as I was writing this, I understood that this is like not only four major, it is six major concept of the persistent storage that we kind of discussed over here. And probably also one thing we understood, that the DB engine, that when we started discussing this part, we talked about this thing that there is a host machine, and this host machine will be having this the host machine will be keeping this database, right? So what happens is this host machine will have all those pages, right? All the page that we were talking about, these are OS pages, and then these pages are being given into the database pages, and database pages are entirely different from this OS pages. Okay, and like it has different size. For example, if each paging in operating system, if it is 8 KB, it can be 16 KB or 4 KB in the database, so it has to be managed in a entirely different manner. So I hope this part is clear to you, like how for example, what exactly is a flow of a query, like when we are just firing a query into our terminal, and then how exactly it is being written into the disk, and how in our subsequent transaction or in our subsequent disk reads, uh, that data is being read. I think all these things are right now clear to you. So in this process we understood but like one of the very important concepts of WAL, the buffer pool, the background flush of the Fsync as well. To solidify our understanding further, let's take a complete visual timeline of our DB operation that we discussed. Okay, so suppose there is like time t0, take it as a millisecond. I'm just writing 0 for our for the sake of simplicity. So client sends the insert at this time. Then at the t1, what would happen is, like, our executor modifies, considering that the data is already in our buffer pool. Executor modifies page 42. Suppose I'm just making up a number, page 42 in memory, and then the wall record for page 42 is written into wall buffer. Okay, and then what happens is, then at the T3 time, page 42 will be marked as dirty. At this moment, uh, please understand that page 42 already there, residing in our buffer pool, and it is being marked as dirty. Now at um, T4, commit is triggered. Okay, and client receives that, okay, it is being committed. Now at this point, it is very important and imperative to understand that page 42 is still dirty. And how long it will stay dirty, we don't know. Okay, this totally depend on when the fsync will be done. So suppose after that, like in T7, what happens is, like, checkpoint, there is a checkpoint process through which scans the dirty pages, and all the dirty pages are being marked into, so here all the dirty pages are put into the page, put into the storage, and dirty pages are also marked as clean. So this is a very important distinction to understand, guys. Although the commit is being triggered, but at that point of time, page 42 was still dirty, and then probably in a little bit of later point of time, when the checkpoint process is being done, it scans the dirty pages, and all the dirty pages are being flushed onto the storage through the fsync or some other operation. Now, just a question to you: if some other transaction, suppose this is my transaction 1, okay, this whole process that is going on, this is my transaction 1. So right after this, at this point of time, somebody is trying to get the data. Okay, get the very data, like that we inserted, the insert query that we fired at top. What was that? It was a insert into orders table. From the orders table, suppose we are trying to get the value 1, right? It is inserting value 1 and the customer name as Virat. Suppose I am doing some kind of a transaction over here, get the data, and what it is doing is, it is doing some kind of a select star from orders where id equal to 1. So id I just have inserted, it is not even being gone through this checkpoint process. So it is at this point of time, it is trying to execute the query. So now what would happen is, our data is there still in our memory buffer, right? So the memory buffer that we were, this buffer pool that we were talking about, so our data is still there. Okay, and so whatever the data, although it is being not written into the persistent storage, it will read from the buffered pool and it will get the correct results only. So now probably you get a complete idea that how, with this excellent trick, database makes sure that the WL, the durability, is being maintained, and this actual flush happens in a periodic manner, so that like IO operations are always expensive, right? Like this part, if you see, this is this IO operation, this is a IO operation, right? So this IO is always expensive. So this approach of this checkpoint process of scanning dirty pages are letting us do it in a batching manner or through a batch process. And that is why the this is a very imperative aspect of the database that as a developer or as an application engineer we must understand, which tells us that input output should be done in a later point of time, and through this linear timeline of this DB operation, we get the idea that how the data is being inserted, and from that same dirty page the other transaction will read the data. So it is completely fine, like there is no way we could get into any kind of wrong data state at any point of time.